Right. Serious time. Can anybody remind me what dy dx tells us? What does dy dx tell us?
You
Gradient.
change in Y or change in X.
If you say gradient, you can't just say gradient. It's actually the gradient function. The gradient function. And it tells us the gradient of the normal or the tangent. Do you all remember that?
Tangent.
The tangent. Good. So we would have looked at first principles, which is the concept behind differentiation. You know, you want to find the gradient at a specific point, but you're dealing with a curve. You can't just, you can't just take 2 points and find the gradient in a line. So what they decide to do, they take 2 points, and as you make those 2 points closer together, that gradient approaches the actual gradient. And so the definition of the derivative is a limit as the distance between the 2 points becomes 0 of regular gradient formula. So that's what the definition of a derivative is. So let's look at a couple examples, since we are done with first principles. The most common one you have to deal with, so let's just say you had y is equal to x to the power n. Now we have a function y, and the function is in terms of what? Does anybody tell me?
X.
Is in terms of x. So we're gonna differentiate y with respect to x. Now, when you're doing this, it's literally like, it's very simple. It's just going to be, anybody want to tell me? I presume I would do differentiation before Cassidy. If I differentiate x to the power n, what would that look like?
It would be x by n and then n minus n.
Right, so n, you're gonna multiply, so you're gonna pre-multiply, right? So you're gonna take the power and you're gonna multiply that by the entire thing. You're gonna write back x, and you're gonna take away 1 from the power. So let's look at a couple examples of this. Right, so Jenna, let's say for a moment we had y is equal to x to the power 3. So Jenna, differentiate that for me.
3x to the power 2.
Cool, 3x to the power 2. If I had something like phi is equal to alpha to the power 7, Nathaniel, how would I write the notation for that? Would I write dy dx?
Sorry, sir, you could repeat?
Like we catch Nathaniel lacking there, or?
Yeah, sir, they catch my lacking, sir.
Yeah.
I lock in.
You should know by now what is calling everybody in class, so you gotta lock in, otherwise I'll catch you lacking. So
Yeah, my bad, sir. I lock in.
So Nathaniel, you could just remind me how I did this. How did I get 3x squared? How did I get 3x squared? How I get 3x squared?
Oh, because it's sir, I don't know.
Alright, so when you are differentiating, so I have the function y here, so I'm going to differentiate y with respect to the variable x. So I say dy dx, and how it goes is I'm going to multiply the entire thing by the power. So I put a 3 in front, I write back x, and I take away 1 from the power. So it was 3 here, so I drop it down to 2. So let's just say I had a function here phi in terms of alpha. How would the notation for that look like? Would I write dy dx?
When you write dy dx, it will be phi alpha 6.
Wait, I'm asking for the notation. So would I say dy over dx, or would I say something else?
Oh, you would say dy dx. No. You would say
The symbol is called phi.
phi and
The symbol is called alpha.
alpha. D phi and D alpha.
Yes, d phi on d alpha. The reason I'm doing this is to let you all know that no matter what the symbols are, it's the same concept. So tell me, Nathaniel, how would I work that out?
You would multiply thing by alpha.
I'd multiply what?
You multiply.
So look at this example.
What?
Look at this and tell me what to do here. What to do?
You multiply.
I'll multiply.
I know you multiply by the power. Right.
So you here. Tell me the answer. Tell me the answer. Answer let me correct.
Seven phi alpha.
No, this is as alpha. So it'll be 7 alpha to what power?
Or to the power of 6.
Yeah. So when you're differentiating something and you form x to the power n, you multiply. So you put n in front, you write back x, and you take away 1 from the power. That's all.
Okay.
That's all. I'm not done with you. Alright.
Okay.
Let me just say we had z is equal to y to the power 4. Actually, you know what? Let me just say we had y to the power a half. What to do here, Nathaniel? And I hope the rest are paying attention, you know. Well, I'm not too worried about Virginia. Right?
It would be
Cassidy, wait, Cassidy, did you go back to sleep?
No, sir, I'm locked in. I'm locked in.
Okay. Jenna, you alright? You awake?
Yes, sir.
Akamaya, you good?
Yes, sir.
So I want you all to tell Nathaniel if he's correct. So Nathaniel, tell me what the symbol would look like.
Okay, it would be dz over dy. And then it's a half y to the power of what, negative a half?
Yes.
Yeah.
Ladies, could any of you all tell me why it changed to the power negative a half?
Because a half minus 1 is negative.
Cool. While we're on this topic, when you're dealing with these types of questions, generally speaking, they'll be fine if they see a negative fractional power, because the main topic is not surds or indices. But y'all are better. So let me explain something for a moment. And Jenna, this should resonate with you, because we're doing surds and indices in the Form 4 class. So let me explain something, guys. Numero uno. If I have something like x to the power negative 1, what's another way I could write that? X to the power negative 1 really means what? 1 over x, right. Nathaniel, if I have something like x to the power a half, what does that mean?
That means it would be what is now 1 over x?
Tomo? I really put in Nathaniel on the spotlight today, boy.
Yes, sir. I feel it. I wasn't ready for this too.
You had to be ready for anything that life throws at you, you know.
Yes, sir, you're right.
Yeah. If life passes you the ball, you gotta score the goal.
Yeah.
Why? Yeah.
Bars.
Right? It can't be like Ronaldo.
Sir, not right now.
Sorry. It's true though. But Nathaniel, okay, anytime you have a fractional power, it suggests roots. So to the power half means square root. So x to the power half means the square root of x. You're not seeing it, but that's understood to be the square root of x. All two there by the square root sign x. What do you think x to the power a third would look like?
3 square root of x.
Not 3 square root of x. Anybody wants? Yes, cube root. So, generally speaking, we could make some generalizations. If I have something to, let's just say it's the power -1, in general that will be what? Anybody want to tell me? If I have x to the power -n, what would that be, Jenna?
N over x.
Now, look at this example a bit more closer. We had x to the power -1, and that turned to 1 all over x to the power 1. So if I have x to the power -n, what do you think that would turn to?
N over x to the power of n.
Nah. That would turn to 1 all over x to the power n. And if I were to take x to the power n and bring it up to the numerator, the sign for the power would change and I would get back x to the power -n.
Okay.
So, just to make sure you understand this, Jenna, if you had x to the power -4, what would that be?
1 over x to the power of 4.
Cool. Alright. And we could generalize this statement by saying x to the power 1 over n is equal to what? What, Cassidy?
N root x.
So the nth root x. That's the proper way to say it, the nth root. So these are the generalizations we could make. X to the power -n means 1 over x to the power n. It just means the reciprocal. X to the power 1 over n implies nth root. So let's look at what we have here. We have y to the power -1/2. Anybody want to tell me what y to the power -1/2 could be represented as? What could I write y to the power -1/2 as?
1 over square root y.
Okay, big up Nathaniel. Nathaniel jumped the gun there. He said the final answer. Ladies, all you understand why that is the case or no?
Yes, sir.
Yes.
Because y to the power -1/2 really means 1 all over y to the power +1/2. And we know that to the power 1/2 means square root. So if you want, you could write your final answer as 1 by 1, which is 1, all over 2 root y. There's even further you could go. Jenna, right now we're doing rationalization in the Form 4 class. And you could rationalize this.
Yeah.
How would you rationalize that? Does anybody know what rationalization means? When I say rationalize something, what does that mean? Jenna, you could tell us. I see Kamaya and Virginia on mute. Anybody could tell me.
Multiply numerator and denominator by whatever the denominator is.
Not just that. There's more.
It's, you're
Add the square root.
making another fraction.
No. Somebody said you get rid of the square root of something. Yeah, that's what I want to hear. When you rationalize something, you get rid of the radical from the denominator. So like, you get rid of the square root from the denominator, you get rid of the negative power from the denominator, you get rid of an imaginary term from the denominator. Obviously, you all would know about the imaginary term. You will learn about that in upper 6. But the point is getting rid of the surd from the denominator. So Jenna, how would I get rid of the square root from the denominator there?
You multiply.
Multiply by what on the top and bottom?
2 root y.
Now we'll just multiply by root y.
Oh.
I don't really care about the 2. The 2 is now a surd. If you notice the 2, that's now a surd, right? The only thing I'll multiply by is root y on the top and bottom, because root y by root y is what? What's root y by root y?
Y.
Exactly. Cool. But generally speaking, this is fine. Of course, if you want to be a bit extra, you could even go beyond this and you could give your answer in rationalized form. I have a feeling Virginia might do that.
Honestly, yeah. But honestly, I didn't know that was the purpose of rationalizing.
Yeah,
Like,
the
I used to
purpose.
do it, but I didn't know the purpose behind it.
Again, the purpose is to. Right, let me explain something, right? And this will make so much sense for you all. Stay with me, guys. If I have something like 1 all over the square root of x, by me having the square root of x in the denominator, I am restricting some elements in the domain. Let me explain what I mean. Can we divide by 0?
No, sir.
No, sir.
No. So if I have 1 over root x at x is equal to 0, what happens to my function? Guys, what's the
What
square
is
root of 0? What's the square root of 0?
0?
Can I divide by 0?
No, so it would be
No, sir.
undefined.
No, so at x is equal to 0, your function becomes undefined. Now, stay with me. If you multiply by root x on the top and bottom, it's still the same fraction, it's still the same function, but just represented in a different form. 1 by root x is root x, and in the denominator, well, that didn't really help, because you still have root x by root x, which is x. But, yeah, that didn't really help. But there are some instances where it would help, right? Where rationalizing would get rid of some domain restrictions. And generally speaking, like we typically don't want any funny business in the denominator. Like generally speaking, when you'll do upper 6, you'll see that we don't want imaginary or complex numbers in the denominator, and we have to do the same procedure. I guess it's a convention, but I guess the fraction looks nicer if they don't have any funny business in the denominator. I suppose so. But anyways, cool. One more example, and I'm giving you all to do this by yourself. Let me just say we had L is equal to 7t to the power 4 over 3. I want you all to attempt.
I have a question.
Talk to me, Kamara.
What we doing? Like, what is for?
Okay, so you remember in the previous classes how I would have showed you first principles and the concept of differentiation?
Yeah.
Right, and you had to do this long working.
Mm-hmm.
Right. So let me explain something. When we did these questions, you would have noticed something. Watch, look at this for yourself. F of x is equal to x squared minus 8. When you differentiated that, what did you get?
2x.
Come on, you see that? You get 2x, right?
Yeah.
So mathematicians would have done first principles and they would have tested it for all cases, and they would have came up with a general formula, meaning that you don't have to do all of this every single time you have to differentiate. So what we are doing is the generalization on what we've done in the previous classes. And what I'm trying to say is we like circumventing all of that, we like just ignoring all of that, and we jumping straight to the answer. So like if you see x squared minus 8, you use your rule. So if you have x to the power n and you differentiate it, that'll be nx to the power n minus 1, as opposed to doing all of this. You understand? So
Yeah.
instead of doing first principles, since we already know how the derivative behaves, we could just use fixed derivatives. Like we know what the derivative is going to be, so we're just using that, as opposed to doing any long working. So like
Okay.
instead of using first principles to figure out the answer is 3x squared, we could just do that, because we know that this is like a defined derivative. It's a known derivative, right? So that's what I'm trying to teach you now. So we're currently finding the first derivative of functions. I'm going to go through all these standard cases with you all. So the first standard case was y is equal to x to the power n, right? And to differentiate that, this is what you would do. And that again, this comes from first principles. This is a generalization from first principles. Alright, so you guys, I want you to attempt question 4. I'm giving you all 2 minutes. So in 2 minutes, you should have an answer. So like 5:41. Okay, so that's now I mean Virginia.
Oh.
I want you to differentiate it. I want you to find the first derivative of that function.
Oh, okay.
I want to see what y'all gonna do.
So we just have a minute extra than 2 minutes.
Sure.
Okay.
I kind of give you all an oddball, but I don't think it should be that bad. Right, Serena. Serena, you're so quiet. You okay? Okay, good. Let me check what you did here. Yeah, that's correct. Wait. I'm seeing some soft stuff over here. You had 28 by t to the power of 2, right?
Yes, sir.
So, is 28 being raised to the power of 3?
No,
What's being raised to the power of 3?
just T.
Just t. So in the last line, I saw you wrote the cube root of 28t, but that is inaccurate. So fix that. That would one thing you gotta fix that. Jenna, let me see what you do here. Oh, Jenna, you make like a similar mistake. Alright, so Jenna, I'm gonna ask you the same question I asked Serena. What is being raised to the power 1 over 3? Is it the 28 over 3? Or is it the t? Exactly. So if it's just t that is being raised to the power a third, then it'll be the 28 over 3 by the cube root of t. If you understand what I mean.
So then, my first answer is correct, or
dl dt is equal to 28 over 3 t to the power of 2. That's correct. The last line you wrote is wrong because you're saying cube root of 28 over 3 t. But that doesn't make sense because only t was being cube rooted, not the 28 over 3. Cassidy, let me see what you have here. Yeah, Cassidy, that's correct. Right. So let
Like
me.
more slanted working like yours.
I don't like
I
how
was
you, I don't like how you put the equal
everything
value
to
dt.
someone like
So if I'm differentiating, I'll be differentiating L with respect to t, so that's going to be dl dt. The first thing I'm going to do, I'm going to pre-multiply. So I'm going to multiply the 7 by the 4 over 3. 7 by 4 over 3. What will I get?
28 over 3.
I'll get 28 over 3. And then I'll take away 1 from the power. So I'll get 28 over 3 by t to what power?
a
Nice. Now I'll ask you all again. What is being raised to the power a third? What is being raised to the power a third? Is it the 28 over 3, or is it t, or is it both?
Just
Just the t. Jenna, Serena, look at this carefully. Are you seeing 28 over 3t in brackets to the power third? Jenna and Serena, talk to me, guys. Let me know if you all seeing. Now we're not seeing our brackets. So the only thing that's being raised to the power at third is t. So what will my final answer look like? If you want to write it in third form. Tell me, Jenna, what would the final answer look like?
28 over 3 root t.
28 over 3. You wouldn't say you'd have to be specific. Since it's to the power at third, it's going to be cube root
Oh,
t.
cube root t. Yes, sir.
That's the answer. Nice.
Okay.
Are we okay with the most basic form of differentiation? Talk to me, guys.
Yes, sir.
So,
Alright, nice. Now, this is one case. There's also the other case where you have y is equal to ax to the power n, which is like it comes from the first one, obviously. It comes from the first one. So, anybody want to tell me what this would look like if we differentiated that? Cassidy, I want you to tell me. If I differentiated something in the form y is equal to ax to the power n, what would that look like?
and it would be n by a and then n minus 1.
Yeah, tell me the symbol.
Okay,
So,
dy over dx. It would be n ax n to the power of 1 minus 1.
cool.
Yeah.
Let's look at some specific examples. 5. Let's just say I had y is equal to 5x. Now I'm going to explain something here and it's going to blow your mind. Remind me, dy dx, or the first derivative, really tells us the what? What does it tell us for the function? What does it tell us?
The gradient function.
It tells us the gradient function. Now, Nathaniel, this is the equation of our what? You tell me, Nathaniel, that's the equation of the what?
Of a line.
Of a line. And the equation of a line is look like y is equal to mx plus c, I agree?
Yes, sir.
Where's m? What's m?
Gradient.
What's m in this equation?
E.
Wait, m? So we know m is a gradient, but what is it over here? I heard you say k.
Oh, I don't realize. Oh, 5.
5. So does everybody understand for this equation, the gradient is 5?
Yes, sir.
Cool. So what do you all think dy dx would be? Remember, dy dx is a gradient.
Function.
Now, in this case, would you say that 5 is a function? Yes or no, guys? Would you say 5 is a function?
I don't think so. I don't know.
No, sir.
I would not call 5 a function. 5 is actually a what? What do you call 5? 5 is a what?
Constant.
Okay.
5 is a constant term. Now, what does this tell us? This tells us that between any 2 points on this graph, the gradient will always be what? What will the gradient always be?
5.
Exactly. So, does it make sense for you all? This is our straight line. Does the gradient for a straight line ever change?
No, sir.
No, sir.
No, it doesn't. So then the gradient will always be 5. Hope that makes sense.
Yes, sir.
So what I'm trying to say is, if you have to differentiate, something in the form ax your answer will always just be what? What do you all think?
A.
A.
Right, because that represents a straight line graph. That's what it represents. And for a straight line graph, does the gradient ever change?
No, sir.
No, sir.
No, it doesn't. So if you see something in the form ax and you have to differentiate it, it's just a. If you wanted more proof, let me show you what this would look like algebraically. You're not seeing it, but what power is understood to be here? Let me just remove the 7 for now. What power exists there? You're not seeing it, but what power exists?
1.
1.
That's the power 1. Let's apply the same thing we've learned thus far. So we're going to multiply 5 by. We're going to multiply 5 by, guys.
1.
X power 1 minus 1. Oh,
And then you're going to do what with the power?
Minus 1.
Right. What's 5 by 1?
5.
5 by 1 is 5. What is 1 minus 1?
0.
No, anything to the power 0 is
1.
1. Because x to the power 0, it really means x over x. That's what it really means, right? Yeah, you could do it for yourself. Watch. If you apply the rules for indices here, you divide them and you have the same base. So you're going to end up with x to the power 1 minus 1, which is x to the power 0. X over x is 1, right? And we know that x over x is 1. We know that or no?
Yes, sir.
Right. So anything to the power 0 is 1. So that's just going to be 5 by what?
5 by 1.
Nathaniel, please tell me if you're lost so I could find you.
Nah, sir, I understand.
You sure?
Sure.
Talk to Makamaya. Yeah.
You know the little thing you have in the box over there? Is
Yeah.
it supposed to be dy? Or
No, it's
is
not supposed to be. It's not supposed to be dy. Let me explain something. Right? This is just another form of writing a derivative. Let me explain. When we say dy dx, it means that I'm differentiating the function y with respect to x. Watch this and it'll make a lot of sense. When I write d phi d alpha, another way I could write that is d alpha to the power 7. Look at it for yourself, Kamaya. What's alpha to the power 7? What does that represent?
I forgot the name of the symbol.
Phi.
Yeah, phi.
So if I wrote d dx alpha, what's in? If I wrote d alpha to the power 7, you know what, Kamaya? This and this means the same thing. You understand?
Yeah.
Because alpha to the power 7 truly is just phi. So it means the same thing. Just another way of writing it.
Okay.
Cool. So do you guys understand why the derivative of ax is just a from both standpoints, from the standpoint of a graph and the standpoint of just applying the formula we learned just now?
Yes, sir.
Yes, sir.
Right. Are you sure? Jenna, you okay or you're confused? Talk to me, Jenna.
No, I understand, sir.
Yeah, sure.
Yes, sir.
So please remember this. I do not want to see anybody making this mistake. Next thing we're going to look at is differentiating a constant. Let me ask you all something. If I have something like y is equal to 7, right? Y is equal to 7. What's that? Like if I draw on my graph, what's that? What's that?
Nothing.
What's
That-
that?
Okay, that's just a line. Does the gradient ever change?
No, sir.
No, so the rate of change. Well, mass. Okay, even I bet I'm gonna blow some of your minds here, right? Are you seeing an x here? Are you seeing an x here?
No, sir.
No, you're not seeing an x. So I really hope this makes sense, and I really hope all you understand this, because I think all you I think some of you guys will be mind blown by this. Wouldn't the line y is equal to 7 look like this?
Yes, sir.
Okay. So question. When x is 1, when x is 2, when x is 3, when x is 4, when x is 5, what is the output?
7.
Always seeing that with all your own eyes, right? No matter what the x value is, the value for y is what?
7.
So, does y change with respect to x?
Yes, sir.
No, sir.
Jenna, does y change with respect to x?
No, sir.
Do you okay? I feel like I lost you. Do you understand what I mean when I say that one? You're just saying it.
I think I understand.
Let me go over that one more time, Jenna. So Jenna, do you understand the graph of y is equal to 7 will just be a horizontal line passing through 7 on the y-axis?
Yes, sir.
Right, Jenna, when x is 1, where's the y value?
7.
When x is 2, where's the y value?
7.
When x is 3, where's the y value?
7.
Okay, point is, when the value for x changes, does the value for y change?
No.
No. What dy dx also means, it tells us the rate at which y is changing with respect to x. So when you look at this example, is y changing with respect to x?
No.
No. So then the rate of change would be what? Since it's not changing, what number would I put to say it's not changing?
0.
0. Yes. Do you all understand that? Please tell
Yes,
me
sir.
if you understand it.
Yes, sir.
I don't understand the concept, right? I'm not hearing from Nathaniel. Come on, I gotta talk to Nathaniel. I gotta buff him up.
I don't know
I
what
don't
you're
know.
doing.
I don't know what's going on with
Not
Nathaniel.
laughing.
I gotta talk to
I
you, father.
want to.
Father, go give them
understand.
licks. I'm joking.
I'm gonna tell you, father, to give him next.
Oh no.
Right? Nathaniel, here what? I want you to explain to me, using this graph, why dy dx is 0 for a constant.
Alright, so dy dx is equal to 0 for a constant because based on this graph, if you look at all the x values on the graph, the corresponding y value is always 7, meaning that the change in the change
You're going good.
yeah. I don't know what else to say, meaning that the change would be equal to 0. I'm missing a part, but I
Yes,
don't know.
yes, the change. Yeah, they had to be specific. So the change in y
Yeah.
with respect to x gonna be 0.
Okay.
So long story short, if you differentiate a constant, literally it's just 0. I don't want it to just memorize formulas and thing. I want it to understand why. Like why this even making sense. Well, I know Kamaya would like she would always ask why. So I like that. Kamaya is one person I feel like you can pull a smarts on Kamaya. I don't think you could do that.
As we caught off that sometimes. Low key fumble.
Loki.
Yeah.
So
That's okay though.
Kamaya, if I find the derivative of a, what that will always be equal to ddx of a, where a is some value.
0.
0, always 0. Okay? Everybody okay with these rules here?
Yes.
Yes, sir.
Good. Let's look at some harder examples now. Let's just say we had y is equal to 7x squared plus 3x minus 9. We're going to differentiate y with respect to x. And when we do this, we're finding the rate at which y changes with respect to x. Also, when I find dy dx, I'm finding the gradient function of the normal or the tangent.
Tangent.
Good, the tangent. Nice. So, who wants to help me differentiate this first one? Any volunteers?
Sure, sir. I don't mind.
Well, I was alright. Come Virginia. Let me do it.
Okay.
I'm not gonna deny you. Alright, let me go.
Alright. Okay, well, you have to multiply the power by 7, so 14x, because you'd also minus 1 from 2, which you just
Mm-hmm.
and well, you can just put 3 because when you differentiate anything like that, it's just 3.
Yeah.
And there's no reason change for a constant, so plus 0. So just leave the function as 14x plus 3.
How we feeling about that, guys? How we feeling about that?
So
Normal.
Easy?
Normal.
Easy or hard?
Yeah.
easy.
Easy.
Oh, I want to explain something to you all there. So I showed you all the graphical intuition for y is equal to 7. Let me show you the numerical significance of it. So if you have
Well,
y is...
Nathaniel said he bad.
He say he what?
Bad. He
He
answered
bad?
too good with that.
Oh, he say he bad. Alright, Nathaniel, let me run it back again, right? Nathaniel, you there?
Yes, sir. I did.
Alright, so Nathaniel, how... Okay, so if I have y is equal to 7x squared plus 3x minus 9, we could actually differentiate each... We could actually differentiate each term individually, because differentiation is a linear process.
Okay.
You don't really have to worry about the linear process much, but just know we could break up each term into small derivatives. So Nathaniel, if I differentiate 7x squared, how am I doing that? How am I going to do that?
You're gonna multiply everything by the power, and then the power itself would just be your minus 1.
Right, so 7 by 2 is?
14.
And then I take away 1 from the power, so what's 2 minus 1?
1.
Right, so I don't know how to put that, but it's there.
Yeah. Yeah.
If I differentiate 3x, what would I get?
You would get. Oh, but you would.
So that again? So let's look at it again. If I have, like, let's just say I want to differentiate 5x, right? If you differentiate 5x, that would just be 5. So anytime you differentiate in something in the form ax, it's always just going to be
Oh,
equation.
right. Okay. Okay.
So if I differentiate 3x, that's just 3.
It's
The
just
last
3.
one, we have a
Yeah.
constant. If I differentiate a constant, what are going to be?
It's 0.
Remember, we talk about that. You yourself explain it. Constants have no rate of change.
Yeah.
So I just plus 0, but I don't have to write plus 0. You know?
Yeah.
Alright then. Before I move on, I'll just explain something real quick. I think you'll deserve to see this. Anything to the power 0 is what? Remind me. Anything to the power 0 is? Anything to the power 0, drum roll please, is?
1.
1.
1. So we could actually write 7 or 7x to what power?
0.
The power
Ah,
0.
Wait, it's not 0?
power 0, right? Because 7 is the same thing as 7 by what? So Makamaya, 7 is the same thing as 7 by what?
X. No.
Nah. 7x and 7 is not the same thing.
Okay.
You what
By
thinking?
1.
By 1? Yeah.
Yeah.
Guys, we're 7 by 1. I promise I'm trying to trickle you up, right?
7.
7. 7 by 1 is 7, we know that. Now 1 could be represented as x to the power 0, yeah?
Yeah.
Yes.
Right. So now it's in the form ax to the power n, where a is 7, x is x, and the power is 0. We see in the parallel.
Yes.
Now, if we apply the same rules we just learned, tell me Nathaniel, how would I differentiate that? Seven x to the power 0. How would I differentiate that? So remind me, Nathaniel, what do you do the powers?
Oh, okay. You will multiply by the power.
So this would be what? You tell me.
Yeah, it would be 7x, 0 times 7x, sorry.
So 7 by 0,
Oh,
and then you understand?
yeah,
So like you're multiplying everything by the power. So the power is 0, so that's going to
yeah,
be 7 by 0, and then you're going to take away 1 from the power.
yeah,
So 0 minus 1 is
-1.
no. Although it's 7 by 0. What's 7 by 0?
Zero.
Zero.
0.
And 0 by absolutely anything is just
It will always be zero.
exactly. So if I have 0 by x to the power negative 1, I don't care what x to the power negative 1 is. That answer will always be what?
0.
Zero.
Will
Zero.
always be 0. Will be 0 every single time. So this is the numerical way of showing it. Hope you understand.
Yes.
Nice. Let me give you all some questions quickly. Just so that I could assess where you all are at. Y is equal to minus 9x to the power 4 plus 3x to the power 2 minus 1 all over 3 x to the power minus 1. Right, so I'm going to give you all 2 minutes. Try question 8. And if you don't get through with it, that's fine. Again, I'm here to help you all. We're learning. Don't feel shame. But I'd rather you all try and fail than never try. I was going somewhere motivational with that, but
It's better to try and fail than fail to try.
yes. Thank you. Thank you, Cassidy. So give question 8 a try. Serena, I know you're real quiet. You okay, Serena? Everything alright?
Yes, sir.
Alright. Alright.
Wait just now, so I had to do over something to watch science.
Alright, I wouldn't launch it yet. Jenna, you made a small mistake. Um you did this correctly. You did this correctly. I don't know what happened to this. You gotta take your time. You gotta differentiate that for now. Right? Jenna, you gotta run through that again. It didn't differentiate this one for now. I just see the first two.
Wait, sir, I think I make a next mistake. Just
Yeah,
now.
you make our next mistake. Take your time. Yeah, that's correct, Virginia. Nice.
Yes.
I haven't seen any of you all like what was going on. We boy.
Sorry, so time's kind of rough right now.
I see, I see. And
Sir,
well,
my hair's still undone, so
yes, boy.
I don't know what to tell you.
I don't know what I'm gonna do. You know what we're gonna do? When class ends today, we're gonna
What's
sing. We're gonna sing, right?
Oh,
We're gonna sing for Cassidy, cause you know the other day was Cassidy's birthday.
I see, I see.
Aww.
Jenna, still not 100. So remind me, Jenna, when we differentiate, what do we do with the power?
You multiply it by the
Nah, you don't multiply the power. So like, look at this for instance.
oh, you minus one from the power.
You minus what? How much?
Minus one.
minus 1. Look at this example, for instance. Over here was 2, and over here it's to the power 1. So you take away 1 from the power. So I saw that you wrote, I think you see
As you had,
it.
yeah. Okay.
Cassidy, that looked like
You
I
see
left
always favoritism. Yeah, well, you're not checking my work, you checking
Oh my.
Cassidy work before you check my work,
Oh,
sir. Wow,
Hey
sir.
boy.
I feel
hey
it.
boy.
Wait boy. Kamaya digging horrors for real, for real.
Come on, running a strict program.
Yeah.
Yes, of course.
Cassidy, that looking like 113. That looking like 113.
That's a slash, okay? That's how we save space on the page, right?
Okay.
That's 1/2. That's a third.
But yeah, that's correct. Nice. Nah, Jenna, you're still making a little mistake. So, Jenna, we taken away 1 from the power. So, Jenna, if the power was negative 1, if I take away 1 from negative 1, what would that be?
-2. My
Yeah.
bad.
Negative 2. Kamaya, before Kamaya stone around. So, this is neglect. I waiting to get answer
It's
from
the
Nathaniel.
one
You
we
know.
go both around.
I waiting to see an answer from Nathaniel. That is why I wait. I waiting. Nathaniel is the only one here representing the boys, right? Nathaniel, lock in.
Oh no, okay, so just
Yeah, come on, that's correct.
Thanks. Finally. Thanks.
You're easy, you know. Yeah, that's correct. That's correct, Serena. So Nathaniel, I'm waiting to see what you do. Nathaniel, if I keep catching you lacking or like you're not sending me anything, I will have to report to your dad. I don't want to have to do that. So at least try something so I see what's going on. Right? I wanna at least see you trying something.
yes, sir. I just moving slow. I send them.
I just wanna see that you're doing something. You're trying.
So Nathaniel father is a big black Jamaican man. You can't send
Why?
back
Why
to
you
the
making
world.
everybody
Whoa.
say that?
Boom boom. Boom boy Ross. And he thought I would beat him. Very well. Right? Oh. So, Nathaniel, see. Wait, just to make sure we're on the same page, did you think that this was a 8 or a 9?
A.
Nah, that's a 9.
Oh, okay.
Yeah. That's okay. Alright, so Nathaniel, let me lock in and get this right. First things first. If you differentiate 5, what I'll be? If I differentiate 5, what are gonna be?
0.
Right, so at least we know that. We know that for sure. And then we're gonna differentiate y with respect to x. So when you're differentiating, you multiply. So you're gonna multiply this entire thing here by what? What are you gonna multiply this entire thing by?
4.
You're gonna multiply that by 4. And so that's gonna be 4 by
9. But minus 9.
what's 4 by minus 9?
Minus 6.
Minus 36, right. And what are you gonna do with the power?
Minus
Right? So 4 minus 1 is?
3.
Right. Over here, what am I going to multiply everything by?
2.
2. So that's going to be what?
6x.
Ah, right. 6x. And don't have to put to the power 1. I don't need to do that.
Yeah.
6x is fine.
Yeah.
Okay, this one might be a bit tricky. We're going to multiply everything here by what?
-1.
Good. And specifically, what number am I going to multiply by -1?
Minus a third.
Right. What is minus a third by -1?
Third.
Positive a third. So you put plus here, plus a third. You're going to write back the x, and we're going to do the power.
-1.
Right. So you're going to end up with -1, which is
-2.
good. And if you differentiate 5, that's just going to be what?
0.
Good. There's more you could do. So you see that negative. Wait a. So over here we have a third by x to the power -2. X to the power -2 really means what? What does that really mean?
Is it'll be 1 over power.
You got this. Right? So x to the power -2 would actually be 1 over what?
A third x to the power 2. Oh, x to the power 2. X to the power 2. Yeah.
Right? So it's going to be 1 all over x to the power 2. So negative powers imply that they're going to go in. Okay, if it's a negative power in the numerator, you'll send it in the denominator. If I had something like 1 over x to the power -2, I would take the x to the power -2, I would send it on top, and that would become x to the power 2.
Yeah.
So if I have x to the power -2, that's the same thing as 1 over x squared. Right. What's the final answer going to look like? By the way, guys, if you wrote this, full marks, full marks. That's all you had to do. That's literally all you had to do. You get your marks. We're just doing extra here.
Yeah.
So-
So it would look like 1 over 3x squared.
Good. 1 over 3x squared. So, Jenna, you understand? I feel like you was overthinking it a little bit.
Yeah,
You're just taking away. You're just taking away 1 from the power. Whatever the power is, you're taking away 1 from it.
Yes, sir.
Okay, that question was far too easy, and I need to introduce you all to the pits of hell. I think so. All you think.
I
That's
just
I good, right? Yeah.
Right, differentiate that now. Let me see how they think. Let me see how they use our brain. Because I know all they could use our brain. So I'm gonna give all 2 minutes for this. You know what? I'm feeling generous. Take out 3 minutes. Take out 3 minutes. Right? So again, at least attempt something. Attempting something is better than attempting nothing. Come on, yeah. Do that fast, boy. Let me see. Let me see.
That I cannot hear.
Okay, yes, taking out all. That's correct. Okay.
That's great.
Clock it. Now, if you wanted, you could have do a bit more working. You could have
Yes,
taken
sir, but
taken on.
I not extra like all you. That is a big lie, but that is okay.
Hey, it's not hard, Like you could definitely Work
Yes,
more.
I could do it. I
Then do
just
it. If you could do
don't
it, do
want.
it. If you could do
All
it, do it.
right.
If you could do Some days you're gonna get off the bed and you're gonna be like, I'm not gonna be able to brush my teeth. You should probably be able to brush your teeth. You
All
know?
right, sir. All right, sir.
Alright, so Virginia.
Yeah.
So it's not entirely correct.
So,
A negative power does not mean a negative sign. So
oh,
if I have something like x to the power negative a half, it actually just means 1 over x to the power a half.
okay.
So
Into
let me run over that one more time. So if I have one, wait a if I have x to the power negative n, that really means 1 over x to the power n.
okay.
And so if I had something like x to the power negative 7, that would actually be 1 over what?
7.
Yeah. So if I had x to the power negative a half, that's really 1 all over.
Oh, square root of x. Because it's.
Yeah. Square root of x.
Oh, okay.
So if you see a negative power, that just means you have to reciprocate. That's
Okay.
all. That's all. You gotta reciprocate. So if you have x to the power negative a half, you're gonna write that as 1 over x to the power a half. If you see x to the power minus 7, reciprocate that, that'll be 1 all over x to the power 7.
These are like things I fumble in a little bit sometimes.
That's okay. Even the best of us make mistakes, so it's fine.
Well, I'll just try my best.
Nathaniel, let me see what happened here. So, right, yes, yes, they're going good.
Favoritism again. I see.
What? In the second to last line, mistakes happened. So we go work on that. Here what? If you guys know you're gonna have some problems simplifying it, leave it. Leave it alone. Alright? But I did say try. And you did try. So I can't say anything bad. You did try. Cassidy, I see how you could lose marks for the way it looks. Because
Okay.
if you ask me, that looks like 1 all over 2 x to the power negative a half. But I think you really mean a half by x to the
Yeah.
power negative a half.
Yeah.
So maybe that could be a reason why they lose marks in exam. Like probably.
Probably.
So you gotta look at that. Right? So alright, so Serena, see you had some little technical problems, so let me run it together, right? So Serena, if you see the square root of x, wait, before we even do anything, right now, is it in a differentiable friendly form? Like is it friendly right now? No, it isn't. So far in this class, we learned how to differentiate something that's in the form x to the power n. None of these are directly in that form. So we need to put it in that form so we can differentiate it. The square root of x actually means x to the power a half. Right, Serena?
Yes, yes.
Right. So you made a little mistake there. And then if we have 1 over x squared, it means that we're gonna take the x squared in denominator and we're gonna bring it up to the top. What that's gonna do, that's gonna change the sign from a positive to a negative. So that's gonna be 1 multiplied by x to the power negative 2. You don't even have to put 1 here. Right? So the only mistake you made was that square root. Tell me what to do
Yes.
from here, Serena.
Now you would see a half of x to the power negative a half.
Mm-hmm.
plus, no, minus 2x minus 3 to the power minus 3.
Good. So if you had up to this point, that's fine. That's fine. Don't do no more. Alright, so Cassidy is what I'm talking about, right? Your working looked like it was 1 over 2x to the power minus 1 over 2. You don't
Oh,
want that. You want to clearly state that it's a half by x to the power negative half. Right, so let's move on to the optional steps, like we could do additionally. So Nathaniel, pay close attention to this. So tell me, Nathaniel. So we have a half. So Nathaniel, a way to take your time here, right? So we have a half. You see now, we have a half.
Yeah.
And we're gonna multiplying that by x to the power negative a half. Now you tell me, what does x to the power negative a half mean?
It would be 1 over square root x.
Right, 1 over the square root of x.
Yeah.
I write it like this for a specific reason. So 1 over 2 by 1 over root x. So from here, it's easy because you know 1 by 1 is 1, and this is
Yeah.
just going to be 2 root x. Nice. The other one, be careful, right? Some of you all might make the mistake and you might put 1 all over 2x to the power 3. How much of you guys were tempted to make that mistake?
Well, I think I did it. So yeah.
Alright, I see. Let me ask that question, Nathaniel. What's the only thing here that's being raised to the power minus 3?
X.
X. Just x.
Yeah.
And again, if you having a hard time with this, look what to do. I can write back the 2. If you want, you should no, actually, no. If you want, you should put brackets here. Brackets here. That x to the power minus 3. That's really what? What is that x to the power minus 3? That's really what?
1 over x to the power 3.
So if we simplify this, 1 by 1 is 1, and 2 by root x is 2 root x. And then we have 2 by 1 here, which is, so 2 all over x cubed.
Yeah.
Does everybody understand how I get the final answer?
Yes, sir.
yes, sir.
Right. Let me give you all a couple more. Cool. I would like you all to attempt this one. 3 minutes. I'm just making this abundantly clear. Does this mean 3 by root x? Does that
No,
mean?
sir.
Oh, sir.
No, it does not. It actually means cube root of x. So tread carefully. And again, you could only differentiate something if it's in the form x to the power n or ax to the power n. So you need to put it in that explicit form before you differentiate. Even though we're quiet today, I like the vibes. I feel like decent vibes. Although Kamaya can have x. Don't know what's wrong with
Yes, sir. So you still never check over with the second times.
Oh
I
my.
just rush from out, sir. Even though I get a piece wrong, but it's okay.
Let me see. So you understand what I did, right? I split it up a half, and then I say multiply, and x to the power negative a half, that really means 1 all over x to the power a half. Now x to the power a half really means square root x. And then I'll work it
Yeah.
out. Right.
Yeah.
Jenna, are you okay or not?
Oh, yes, sir. I think so.
Jenna, I know we get into harder territory. So you'll do this question with me, question 10. We'll run it together. But at least try something and send me a picture.
Okay.
Hello.
Hmm?
Turn on the light for me, please.
What?
Hmm?
You want to turn on the light for you? Okay.
Oh,
I guess.
sir.
Look
Why
at
am I
light.
unmuted?
Look at light. Look
Sir,
at light.
my cousin down. Sir, I'm so sorry about that. I don't know why I unmuted.
Next thing you was on a call with Nathaniel, and it was like, Nathaniel, hush him out or something. So
That
today,
sounds like
today I call Mrs. Matt Vibes, and I call she to get her second opinion because I buying her glasses, and she was like, "Why you holding the camera so close so?" Just so I was like, "Whoa,
I
whoa!"
love Mrs. Bad Vibes.
I was like, "Whoa! Why you think that me so violent?" It's like, wait.
because
I on
y'all
her
don't like to
frequent.
listen.
I feel like women so violent.
Just why you holding the camera so close yourself?
I didn't even think it was that bad.
You know, you don't really realize until you're with one, you know. It's just, it just be hiding it.
Nathaniel, what that's supposed to mean? Has something going on in class here that I don't know about?
Sir,
Huh?
Hmm. Hmm.
Huh?
I think Nathaniel got caught
I
up in
wonder,
the
boy.
Hmm. If all you we're probably helping each other with work and thing and we're focusing, you know. I as like I'm like a role model or like an influencer in your life or just
An
tell her this.
influence, yeah.
I don't want to hear nothing about no teenage pregnancy and thing. I just had to say that.
Whoa!
I just had to say that. Right?
Oh my
And-
gosh,
and
sir.
your parents would agree. Your parents would agree, you know what I mean? Your parents would agree.
Of course.
I don't want
So,
to
you
hear
know,
that. Both of you all have a bright future. I just had to say
course.
it. I just
Yeah,
had to say
yeah.
it. Yeah.
So, you know who is, helping me with understanding and maths and physics,
Who's
of
that?
course. Um, on a on a very intricate level. Yeah. When I passed students actually. By pass I mean this this year that went by.
Amy?
No. You have to read between the lines here, so you can't have your millennial thinking for this scenario.
What?
This is why Mrs. Mad Vibes is correlative actually.
Mrs. Matt Vibes did not help you with maths. I don't think she helped you with maths. I don't.
I'll just message you. I'll just message you.
Virginia. I see your rage quitting there. I see like your raging is like, oh. Like, I don't want.
That's no more, sir. I don't.
No. You mustn't say that. You mustn't say that.
Sir, I don't like this.
Cassidy, that has no, I can see that from a million miles away. That like when I was watching, okay, when we was doing like the talent show and you started sing, check Kelani. I was like,
Yeah.
that's not normal. But you see, the thing is, I all age, right? More or less, I know that old, and it's like contrary to Cassidy's belief and saying that I'm an unk. You are an unk as well.
Well, I know I gained
But-
on status yesterday.
But these things gonna happen. Like, are you going to see somebody that hopefully ambitious and not slacking in life, and you might be interested? It's fine. I mean, it's gonna happen regardless. You're young. I was there once, but The important thing is you make wise choices. You know what I mean? You don't let it
Yeah.
take you away from the path. Because, like, whoever you with, the company you're around is very important. It's very important. Even if it's like just friends. Be careful. I didn't have any, so I influenced myself. Yeah. Depressing.
Hey, but at least you find Mrs. Madvite.
At least. At least.
She's a good influence.
I have Tivon as well.
Yeah,
Tivon.
yeah, yeah.
Tivon is my son. Yeah.
Also, I have a quick question.
Talk to me, Jenna.
How much did y'all cover already, like before I joined?
We did log, surds, indices, polynomials. We did circles.
We do coordinate geometry.
Right? That's circles, coordinate geometry.
Yeah.
We did alpha and beta, which is in polynomials. I think I can't really think of any more, but
Well, the logs will do in Form 4 class, right?
yeah, I'll do the logs in
Okay.
Form 4 class.
Because in school we did trig, statistics, and all that stuff, but I don't really understand it, so I just want to make sure.
No problem. And actually, I'm gonna send on something that I'm not released to the public as yet. The public don't know about this as yet. Well, I just didn't release it yet, but my AdMaths crash course that happened this year. It has everything. Have everything. I'll send it to you all now. Everything you could find here. Okay, so Jenna and Virginia, I want you all to combine brains, and let's do this question together. So
Me
Virginia,
and you go fall out, you know, sir.
what happened?
You tell me if I right. Tell me where I reach. If I'm going right.
Nah.
Nah, okay.
Here's what? Here's the biggest problem there. Nowhere did you differentiate. Nowhere. None. Nada. So by you writing dy dx in the second and the third line, that don't make sense.
Okay.
The second line, the third line, that's still equal to y. Any simplification or rearranging you do, it's still equal to y. It's only when you start to differentiate you introduce the dy dx. So if you're asking more about the simplification so far, it looks right.
Okay.
Cool. So Virginia, before I could differentiate this, it first needs to be in the form ax to the power n. If not ax to the power n, that's okay. It just has to be x to some power. So before I could do anything, I need to write it as x to some power. I did not differentiate yet, so I'm gonna write back y. Tell me, Virginia, the cube root of x is the same thing as x to what power?
A third.
Jenna, did you know that or no?
Yes, sir.
Alright, and Jenna, you're not seeing it here, but what power is understood?
0, 1, 1, 1, 1.
1. That's x to the power 1. Cool. Now we have 5 over x squared. Again, I could only differentiate if it's in the form ax to the power n. So Virginia, what do you think I should do?
Oh, bring the denominator on top, so 5x to the power minus 2.
Correct. Let me run. Which one of you guys was able to reach this far? We didn't differentiate yet. We're just preparing it to be differentiated. Let me hear.
Yes, I reach it.
Wait, I think I did,
Wait,
yeah.
so you didn't even tell me if I was correct or right?
Wait, how would it be 5x to the power minus 2?
Wait, so let me just check what Cassidy did. Nah, that's not correct.
Okay.
You know, the thing is, I asked earlier if this means if that means that 3 over cube root or not, and let's say is a cube root. Cassidy, you're gonna make the mistake.
Oh shucks.
I tell
Oh
you it was a
shucks.
cube root. I tell you it was a cube root from the start. Yeah. You gotta read between the lines. You gotta read between the lines.
Hey.
Shots fired.
Wow,
Shots
wow,
fired.
wow.
Right.
Is this your idea of a father-daughter banter?
Yeah. When I have a daughter
Okay.
this weekend, my daughter or my son will get fed up on me. You know, there's this guy on TikTok. He does always be making dad jokes with his son, and his son does just be like pelting and be like, "Oh gosh." You know what I'm talking about?
Yeah.
Yeah.
It will be just like that. It will be just like that.
I love
Yeah.
that jokes. That joke's so funny.
They are. They are. Unless you didn't have one, kind of like my situation, but it's fine.
Like me too. But
It's fine. We live and we learn. We live and we learn.
till
We
we
become.
right.
We rise. We rise. We rise. Right. So I don't want to move on. I know they're confused. Who confused? Jenna, I remember you was asking me why is 5x 5 by x to the power minus 2. That's what you was asking me, right?
Yeah.
Alright. Let's look at the rule quickly. So, Jenna, if we have 1 over... Wait, give me a second. If we have 1 over x to the power n, that's the same thing as x to what power? Tell me, Jenna.
Nx. Wait, what?
If we have 1 over x to the power n, that's really x to what power? Here we go. Now, let me start off a bit easier. Let's just say we had 1 over x. 1 over x is the same thing as what?
X to the power minus 1.
Okay, you know that. Good. Let's just say you had 5 over x, right? You had 5 over x. 5 over x actually means 5 multiplied by 1 over x. See, what more you're confused?
No, I understand.
Yeah, sure. So like 5 over x is the same thing as 5 over 1 by 1 over x. 5 by 1 is 5 and 1 by x is x. I didn't do any madness yet. Now, what's 1 over x?
X to the power minus 1.
Right, and remember you are multiplying, so it becomes 5x to the power negative 1.
Yes, sir.
So if I have 5 over x, that's just 5x to the power negative 1. Here's another way you could look at it. In the denominator, that's x to the power 1. So if I take it and I bring it to the top, it's going to multiply by the 5. So it's going to be 5x, and I'm going to change the sign for the power. So that's going to be minus 1. You understand?
Yes, sir.
What if I tell it in that question is the exact same thing? Like, not literally the exact same thing. Look at it for yourself. So, Jenna, 1 over x. Right? Wait. I not realize your friend's supposed to be in this class. It's weird. One second. Yeah, I was like, why your friend not in class? Supposed to be here. Right? Regardless, on Tuesdays and Wednesdays, well, this coming Tuesday and Wednesday, I'll be having some sessions throughout the day to assist you guys if you're to like answer some extra questions now, right? So I look forward to see you all on Tuesdays and Wednesdays. I'll be doing live sessions. But anyways, Jenna, you feel like you fully understand this?
Yes, sir.
All right. So what if you had 1 over x squared now? What do you think that would be?
1 over x squared.
Yeah, look at this, right? So 1 over x to the power 1 was x to the power negative 1. What do you think 1 over x squared is equal to?
X to the power negative 2.
That's all. So if I had 5 all over x squared, what would that be equal to?
5x to the power negative 2.
Right, because 5 over x squared is the same thing as 5 multiplied by 1 over x squared, which is 5 by x to the power negative 2, which is 5x to the power negative 2.
Okay.
Good. So do you
Next
understand?
question.
Talk to me.
I'm so sorry, Cynthia, but I cannot have to leave like as soon as it's 7 o'clock because I have a week to go sleep.
Sorry for your loss. My condolences.
Thank you.
Let me just finish this question fast and we're going to sing happy birthday for you.
Okay.
Does everybody, please tell me if you don't understand, does everybody understand why 5 over x squared is actually 5x to the power negative 2?
Yes, sir.
Yes, sir.
I was
Right.
lost.
Virginia, are you okay or you're confused?
I'm okay now. I wasn't like 2 seconds ago, but how you broke it down, I understand now.
Let me make sure you understand. If I had 7 all over x to the power 3, what's that equal to, Virginia?
7x to the power minus 3.
Good. 7x to the power minus 3. And this is in the form ax to the power n, so we could actually differentiate it.
Yes.
Now, at no point in time did I start to differentiate as yet. Kamaya, I did not differentiate anywhere yet. So you see me put dy dx anywhere?
No, sir.
I did not do that. Virginia, if I have the same base and I'm dividing, what am I going to do with the powers?
You would subtract.
I would subtract. Jenna, just to make sure you understand what I'm saying, if I had a to the power b divided by a to the power c, what would that be equal to, Jenna?
A to the power b minus c.
Yes. So if I had x to the power a third divided by x to the power 1, that's going to be what?
X to the power third minus 1.
And I'm going to leave that as 5x to the power minus 2 because it's already in a form where I could differentiate it easily. I just said easily. What the hell? What the hell? What? Easily.
What the heck, dude?
What? Yeah, like in maths class, in the form 5 maths class, I said comfortable instead of conformable.
Oh,
Oh,
I literally spelled comfortable.
I get that.
What do you mean? What do you mean I put comfortable? What? It's happened. It has happened. So, Virginia, don't be feeling discouraged or anything. The best of us make some dumb mistakes. Like in my maths exam, for grad 5, I find the partial derivatives and I add it. That's I lose like a little 2 marks.
this
You
is
would-
where I actually fumble. Like all the time, I always fumble right here. I don't know why. I don't know what's wrong with me.
It's okay. It's not that deep. You will learn and you will grow and you'll become a better person. It's fine.
Okay.
It's fine. So, we have a third minus 1. What's a third minus 1? Wait, Habiba just joined. Habiba, good evening. Oh, good night. Let me know if you're hearing me. Habiba? Habiba, don't be scared to talk and sing, It's be real vibes and sing. Don't be scared and sing. In these classes, if you don't talk, pressure. Cause like I can't help you. You gotta talk. So unmute your mic and say hi and sing. Yeah. So Jenna, this is like your friend, right? Y'all are friends?
Yes, sir.
Is Habiba typically shy?
A bit, yeah. Habiba, say hi. Habiba.
Nobody gonna bite.
Natanya.
What? Nathaniel, hey, Nathaniel. Nathaniel gonna and say, talk Habibi. What? Hey, come on,
Sir,
I
you
go
find
just
that
slap
right?
you now.
You find that is right?
How?
Sir,
Come on, I go just slap you now.
I
Wait,
know,
but
sir.
yeah.
Sir,
You
I ready
mean-
to go. I'm fed up. Well, you
That
seen
is nah,
Now,
nah.
so,
I
so
was
you
not
go
taking that.
how
I was
Habiba.
not taking
this?
that.
Wait, no.
So
I
we
was
go.
never taking that. I was never taking that. Mm-mm.
Ah,
Mm-mm.
So we call her Habibi in class.
Oh, you'll call her Habibi in class, which means that
Oh,
Nathaniel
wait,
knows her
wait,
Nathaniel.
outside of class. What? Nathaniel?
Oh,
What going on here,
boy.
Nathaniel?
What?
Nah, boy.
Wait,
Guys,
nah,
y'all
stay,
need
I
to.
swear, I
Nathaniel,
didn't know
how
it
would
was a she. I
Kataya
didn't know it
feel
was a she.
about
I didn't know it
this?
was a she.
How you
I
didn't know
swear.
that? What? What? How you did?
How
Nah,
you
nah.
do that?
That even worse.
Clearly.
That even worse. That
No,
even
no,
worse.
that no
No,
way.
you
Nah,
should.
nah, 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 nah. Nah, boy.
No, you
Wait.
should even
I swear, I swear.
What's up?
I didn't know why people was getting on. I didn't know it was a she. My bad, my bad.
I don't think that better, you know. I don't think that better. But, anyways,
In school, he is 10 times this.
wow. Anyways, Habiba, I honestly, I'm being real, I forgot to add you to the group chat and send you the link. Class started 5 o'clock. My apologies. The session is recorded, so I'll send you the recording after on the group chat and I'll send you the notes. But my bad. Try to get your mic working for the next class. And don't study Nathaniel. So Habiba, what's a third minus 1? What is a third minus 1? Come on, I'll be catching Nathaniel in 4K for more than one thing. It's ridiculous. It's crazy, right?
Exactly, he is just be lacking in too much.
I thought this
We
was
need
a
to.
man.
Anyways, Habiba, what's a third minus 1? A third minus 1? Nah, that's not 2 thirds. You're close, but it's not 2 thirds. Anybody want to tell me what a third minus 1 is?
Is it negative 2/3?
Yeah, it's negative 2 thirds. So that's going to be x to the power negative 2 thirds. Right? Because the negative is by the bigger number. So your final answer is going to be negative. So guys, am I finally at a stage where I could differentiate? Yes or no? Tell me, Jana, yes or no?
Yes, sir.
You say that like you was unsure.
No.
Tell me
No.
why. Tell me why I could differentiate now.
Because we have it in the form ax to the power of n
Right?
or x to the power of n.
So we good to go. So Kamaya, now I'm gonna start to differentiate. Only now. So you see, we start off class real chill and thing, real nice, and now it's like all in the dark ages. That's how it is go. Yeah. If we get Virginia to like rage quit, things rough.
Yes, sir.
Yeah. So now we could differentiate. We're gonna call on Nathaniel. Nathaniel, tell me, how am I gonna differentiate this?
Say you would multiply. Oh. Okay, you would multiply everything by minus 2/3.
Right, so it's gonna become minus 2 over 3 x
Yeah.
to what power?
Minus 5/3.
Wait, so you're gonna pre-multiply and minus 1 from the power.
Yeah.
So I gonna do the full work in a bit, right? Since Habiba just joined. And over here now, you're seeing plus 5 x to the power negative 2. So you're gonna multiply that whole thing, that whole term by what?
You asking me?
Yeah,
Oh, minus 2.
minus 2. So you have positive 5 by minus 2. So Habiba, when I say pre-multiply, I mean that we're gonna multiply this entire thing by whatever the power is. So we have 5x to the power negative 2. So the number here is plus 5 and the power is negative 2. So we're going to multiply 5 by negative 2. 5 by negative 2 is negative 10. And then we're going to take away 1 from the power, so minus 2 minus 1. So that's going to be minus 2 over 3. And Habiba, what's minus 2 over 3 minus 1? While Habiba is typing in the chat, somebody tell me what is minus 2 minus 1.
Minus 3.
Right, minus 3. I'm telling you, like in this class, you have to talk. You have to talk. This is one of them classes where you like just like rock back and watch. Now you have to talk. Zachary, what is minus 2 over 3 minus 1?
So you can repeat.
Don't tell me we catch another fella lacking. Yeah.
No, so I didn't hear. See.
Ladies, all you seeing how the gents will be acting up.
So these fellas, and they just wonder why women just get on the way they do.
I'm telling you. And I could tell you for a fact, I just be doing some stupid things as well. Right?
At least you could own up to it, sir.
Yeah.
Some of them in denial.
You can't be wrong and strong. You gotta own up to it. So Zachary, what is minus 2/3 minus 1? Minus 2/3 minus 1.
So that's minus 5 over 3.
Right. That's the answer, you know. If you had this, it's fine. You'll get full marks. This is what they want to see. Of course, it could be extra, right? But you don't have to be extra. That's fine. The question was already so long. Why would you do extra? But
Yeah,
I'll
sure. No for hard maths. See.
Wait, so could you like be extra for a second? I'm trying, but I'm failing.
Sure, no problem. But before we go extra, let me just sing happy birthday for Cassidy because it go past 7 o'clock. Let me just sing happy birthday for she fast. Right?
So you it's upset.
Right, so I'm gonna start off. 3, 2, 1. Happy birthday,
birthday
to
to
Cassidy.
Cassidy.
Happy birthday to Cassidy.
Cassidy.
Happy
Happy
birthday,
birthday,
dear
dear
Cassidy.
Cassidy.
Happy
Happy
birthday to
birthday
you.
to you.
Right.
Thank you, guys.
Of
All right.
course, of course.
I
You're
feel
welcome.
very appreciative towards you.
Yeah. I can't really try it.
Don't worry. And in the classes, all of we like is like one big family. The Math Vibes
That's
family.
our family, sir.
My
Yeah.
vibes family.
Yeah.
Yes.
Right. All right. Cool. Let's move on. Let me do the extra part now.
I'm gonna leave now.
No problem. You were just waiting for that. We should have sing it later. Yeah, boy. All right.
Okay, bye.
Before you go, Cassidy. Before you go.
Oh no.
I could write x to the power negative 5 over 3 as what? What I could write as?
Should I have say nothing?
When you see a negative power, what I mean?
Roots. So 5 over 3 root x.
You're not wrong, you know.
Like
But you gotta be more specific. Okay, anytime you see a negative power, it means that you're gonna reciprocate it. You're gonna write it in the denominator. So if you see x to the power negative 5 over 3, that's really x to the power 5 over 3. Over here you have minus 10, and they multiply that by x to by what? Cassidy, x to the power negative 3. What's that? If you see, that's what? What's x to the power negative 3?
6 over 3.
Yeah, 1 over x to the power 3. Alright, yeah, you can take your leave now.
Bye, sir.
Bye bye. We have minus 2 by 1, which is going to be minus 2. Then in denominator, look carefully what I'm going to do. I have x to the power 5 over 3. I could write that as x to the power a third to what power? Let me see if you all know indices. This all this is indices, you know. I feel like when I do my indices in the form 4 class, I gotta bring all the way across to that. I'll come. So Virginia,
Yes, I don't mind.
Would you raise to the power of 5? And yeah, that's where I fumble. I think that's indices. It's indices.
indices, yes, indices and series. So you see why I'm doing this just now. But where's a power? Okay, if you have a power, it's a power. What do you do, guys? If you have a power, it's a power. What do you do?
Multiply.
You multiply. You multiply, right? So x to the power a third to the power 5 really is x to the power 5 over 3. Nice. And over here, that's just going to be 10 by 1 is 10. So that'll be 10 over x cubed. Let's finish over here. That's going to be minus 2. Now we have 3 multiplied by x to the power a third. Now x to the power a third is really what?
The cube root of x.
Wait, actually we should do. You'll get. This is what I would recommend, right? I actually recommend you do it like this. So x to the power 5 raised to what power? Power a third, right? Come on, do you understand that both would give me 5 over 3? 5 to the power a third is 5 over 3.
Yes, sir.
Jenna, Zachary, Natania, like if all you're confused, tell me, you know.
Nah, so
I
No, sir.
understand.
So a power to a power means you multiply, right? So if I have x to the power 5 to the power a third, that's really 5 over 3. So we're fine. Look at what I'm going to do here, Virginia. So it's x to the power 5 and we raising that to the power a third. Now raising something to the power a third really means cube root. So it's going to be cube root of what?
X to the power of 5.
Yes.
Oh, I see.
And that's as much as you can simplify it. But you know how to do all of that? Like, this is fine.
I want to do it because I want to understand. That's where I fumble. I like to do things, but I don't understand. I don't know.
That's good. That means you're pushing the limits of what you understand.
Yeah.
And let that be a lesson to you guys. If you want to become better, you have to push yourself outside of the comfort zone. Right? So, do you all understand what I did here? Like, let me ask you a question. Come on, what was I raising to the power a third?
X to the power of 5.
X to the power 5. So that if I was raising x to the power 5 to the power a third, then that's cube root of x to the power 5. You understand?
Yes, sir.
Alright, that's it. Let me give you all some homework. I'll give you all some questions I would push like on the verge of what you understand. So let me give you all some questions fast. Anybody has listened to Drake?
Who don't listen to Drake?
I don't know.
But still, I did listen to Drake. I don't know the rest.
I don't know who this guy feel he is. I don't know if he feel he's special.
I think he does feel special. But it's okay. Everybody, each and every one of you guys here are special. They're special to me. Y'all are like my, don't want to say kids. I don't make me feel kind of old, but in a sense, yeah. But everybody is special in their own way, of course.
Yes, sir. Yes, sir.
So you are special to us as well. How about that?
I appreciate that. It's always be like one way, you know. It's always be like one way it is.
Yeah, I find like teachers ask like, "How are you?" but nobody's asked the teacher how they are.
Yeah, I see in the ball, don't know.
You relax yourself. You relax yourself.
Nah, I don't see you bend your head like I see in it though.
No. Like okay, my how it is style my hair. It always be like a middle part. So over time, like it just splits in the middle. Yeah, but look.
Yeah, I understand.
Like I think it that bad. Like it defined, you know, like the hairline defined, you know, like
Yeah,
So
you're not
the
a
engineering
student. You're
gets
not
it
a
there.
student, bro.
Yeah, it is.
It's fun.
I'm not finding any nice questions. One moment. Nathaniel, I'm feeling self-conscious here, boy. Yeah, boy.
My bad. Sorry, sorry.
I'm joking, I'm joking. I literally make a video and post it on TikTok.
Well, yes, yes.
I small thing, boy. Well, me losing here is not small thing, but I get back my hair
They
somehow.
need to get that checked out. They need to
Yeah.
So,
start
the
Duma
lessons,
ruling.
you don't give enough
I
money.
I have a Dumarol as Dumarol and I'm using Tech Italy products and I have like a hair care treatment line and I'm looking into it. I don't want to lose my hair.
Right, so once you lock in, you will get it back.
But I
Here's
think
the
I losing
thing.
my hair because of all yeah. That's why I think.
No, you're losing here because our university. You say you love maths. You say we here. C-Sec maths is nothing for you, sir.
I was going to say something, but Ole go think I don't love Ole. If I say that.
Clearly not. Clearly
Great.
not. Because if that popping into your mind, then that means something.
Oh, wait. Let me get a second. I have a bunch of questions sorted already here. Let me just give all this some. I don't. We rarely do examples in class. I don't want to see all they just wasting all their time on scratching all their head. I want to see all they attempting something, right? So I'm gonna be giving all the questions and they're gonna do it. You're gonna do the questions, right? Otherwise you're wasting my time. And you're wasting your parents' time. And your time as well. So lock in. Right, Nathaniel? Right, Nathaniel? Right, Nathaniel?
Nathan, so he said he might not work it.
It's a real convenient time. You see your camera not working. Now you mic that real convenient. Hey boy.
He said to tell you, yes, sir.
Is it working now?
Somewhat. None of these questions here really that intense. In the next class I will have to I really trying to baby you all into it, and like to the point where you could handle anything. But I feel like I'm babying you all too much. Too much. I need to like give all your harder questions. So I'm gonna give all you a bunch of questions here. I want you to find the first derivative. Find the first derivative.
So why is that called first derivative?
Because they differentiated the first time.
I don't know that did not answer my question.
Okay. Tell me something, right? Come on. How much times they differentiated?
Once.
Right. You could differentiate it a second time, a third
Oh,
time,
yeah.
a fourth time. So that's the first derivative. Because they
Okay,
differentiated
okay.
the first time. Find the first
Alright.
derivative of the following functions. So let me just say you have f of x is equal to 9x squared plus. That's not an e, yeah? That's not an e, that's a 9. That's a 9.
Okay, sir.
Right? Right? So this is e. Y is equal to minus 3x squared plus 2 over x. That's a cube root and not a tree. Right? Oh, and I got to prepare a nice question for you here. Right? X plus 3 by x minus 7. Well, you can get through with this one. I rate on it. Don't use on ChatGPT and thing, eh? I will know. Because I use ChatGPT myself. So I will know.
So that bad.
So when is
Yeah.
you find the equation of the tangent at P, like just
Right, so-
that is mean the differentiator or
Yes, because let's look at the definition of the derivative. The definition of the derivative is a gradient function. Remember, the gradient for a curve, it changes everywhere. So we need to come up with a function where we could put in x values to find the gradient at that x value. Because again, Jenna, a curve, the gradient changes everywhere. Wait, where that rain come down hard? Rain, rain?
yeah.
Wait! Oh God, again worse! Hey boy! Whoa, whoa, whoa! Nathaniel, where's that one, boy? I'm joking.
That's good, sir.
I'm joking. I feel that rain is Nathaniel tears after Kamaya beats him, you know. I don't know. I feel like Kamaya dread, you know. I don't know. I feel like I wouldn't want to mess with
I
Kamaya.
think your feelings correct, sir. I think maybe.
Yeah. Right? So, Jenna, the first derivative, or dy dx, it tells us the gradient function. Wait, let me show you a visual representation. Watch. Can you see that the slope changes everywhere? Like, okay, I feel like you're confused.
But you know starts?
You're confused or you understand?
No, I understand so far.
Let me make sure you understand. If you were driving up this hill, would it be the same? Okay. Would you have to mash the same amount of gas or brakes throughout the whole journey?
No.
No. When you reach over here, you gotta mash accelerate. When you reach over here, you might want to mash brakes because you're gonna be accelerating downwards.
Yeah.
So, okay, would you say the slope or the gradient is the same for that part over there, that curve? Okay, slope just means steepness.
Yeah.
Steepness. Does it look like it's the same steepness everywhere?
No.
No, it does not. Same way over here, this does not look like the same steepness. So at every value for x, the gradient is going to change. The gradient is given by the tangent at that x value. Look at it again. Let's just say you wanted to find the gradient at this value for x. Let's just say this value for x is 7. What you would do, you would draw a tangent, and that's what we do in maths. You would draw a tangent to the curve at that point, and you would take 2 points from the tangent, and you would use y2 minus y1 over x2 minus x1, and you'd find the gradient. That's the conventional definition in regular maths. So again, if you want to find the gradient at a specific x value, you're going to draw your line, you're going to see where that cuts the graph, and at that point, you're going to draw a tangent to the point. If I wanted to find the gradient over here, I would just draw a tangent to that point. If I wanted to find the gradient here, I just draw a tangent to that point. Okay, look at them tangents. Do those tangents look like it's the same angle? Does it look like it has the same steepness?
No.
No. So the gradient is changing. Hence, we can't just use y2 minus y1 over x2 minus x1. We actually need to come up with a gradient function. And it just so happens, when you find the first derivative or you differentiate, you end up finding that gradient function. So, Jenna, depending on what value for x you put in, you're going to get a different gradient. And that gradient you get is going to be the gradient of the tangent at that value for x. So when you differentiate, you're really finding the gradient function of the tangent. So when they say find the equation of the tangent at P, Let me ask you that question. Do you think a tangent is going to be a curve or a line? What do you think?
A
Oh.
line.
A tangent is going to be a line. This is what a tangent looks like. Like, okay, if this was a curve here, the tangent to this point would be over here. That's a line. Yeah, Jenna, you see that's a line?
Yes, sir.
Right. So they want me to find the equation of the tangent, and we know that the tangent is a line. What's the equation of a line?
Or y equals mx plus c.
Good. Y is equal to mx plus c. So you need to figure out the gradient of this tangent, and again, think, how can you find that gradient? Well, when you differentiate, you come up with the gradient function. And you understand that, right? Like if you differentiate, you find any gradient function. Now, we want to find the equation of the tangent at what point?
P.
At P. What's the x value for P?
1.
Right, so remember what I was telling you. It's a gradient function, meaning that different values of x will give you different
Functions.
different gradients.
Gradients.
Because
Oh,
it's
okay.
a gradient function. So
Okay.
different values of x will give you different what?
Gradients.
Different gradients. Right, that's why we call it gradient function. A function takes in an input and it gives you a unique output.
Yes.
So you need to come up with the gradient function. How are you going to come up with the gradient function from this?
You differentiate it.
You differentiate it, nice. And you want to find the gradient at P. So at P, the x value is
1.
right. So when you differentiate this, you're going to plug in 1 into it and it will tell you the gradient at that point. Good, you have the gradient. Now you need to find for C. To find for C, you could use the point that's given, you could plug it in and you could find for C. Or you could use y minus y1 is equal to m by x minus x1. I'm not sure how well you learn to find the equation of a line, but either one is fine.
Okay.
Yeah. And well, it's okay if you don't understand part 2, right? It's okay. But at least try part 1. At least try that.
Yes, sir.
So, with that, I'm gonna leave you guys. Peace out. Later. Go on day.
Bye, sir.
Bye, sir.
Have a
Bye,
good
sis.
night.